Friends, how are you? Welcome to my YouTube channel Enlightened Mind. Today we will be covering the another topic, which is the electric field due to the uniformly charged rod, but this time we will calculate it at one of its end. So basically what we had done in the previous uh, lectures, we tried to calculate the electric field the uh, at the line perpendicular to the plane and middle passing through the middle of the road, and then we calculated the electric field at the axial line. Now we will do or try to calculate the electric field at one of the edge or at the end of the rod. So suppose we have a point P which is at placed at a distance, suppose x, okay, and the length of this rod suppose is 2a or a, or it can be L also. So what we had done in the previous lectures, we put it as 2a, so this time we also uh, take it as 2a, and then we'll again, because lambda is the linear charge density, which is q upon length of the rod, uniformly charged rod, which is 2a. Okay, so we'll calculate what is the charge on this rod, which is uh, aligned at the y-axis, and this small element of length dy had some charge, okay, and that charge is dq, which is calculated as lambda into dy. That we know, we had done in the previous class, so this time also we'll do it. So that should be q divided by 2a into dy. Okay, and then we'll try to calculate what is the small electric field at point P due to this small element, and that should be in this direction like that. Okay, so that is the small electric field. So again, that can be uh, um, uh, changed, or that can be basically divided into two component, one along the x-axis, which is dE along x-axis, and another is dE along y-axis again. And this suppose is the theta, then that angle should also be theta, and so dE along x-axis should be dE cos theta, and along y-axis that should be dE into sine theta. Okay, so now we will try to calculate what is the total electric field due to whole uniformly charged rod at that point along x-axis and y-axis. That we will be doing. So let us calculate the electric field along total electric field along x-axis. So that should be dE, okay, into cos theta integration, and the length of the rod this time is from 0 to this much, and here the length, here L, length is L is equal to 0, here L is equal to 2a. Okay, so you can put a limit from 0 to 2a. Okay, so you can write here L from 0 to L is equal to 2a. That is the total length of this rod. So that you can write dE, you know, is 1 upon, because the small electric field we know could be written as dE into 1 upon 4 pi epsilon naught dq upon distance. Distance here was from this point to this, so that distance, if suppose this is x and this length is y, suppose along y-axis, so that distance, suppose if is r, should be x square plus y square's root, right? So that should be r square, and because small r is the distance between this and that, okay, small element to point P where electric field is to calculate, so that r should be square root of x square plus y square. So if we'll put this value of r here, so that would become 1 upon 4 pi epsilon naught dq, which is lambda into dy, r square is x square plus y square. Okay, so you can put this value here while you will be calculating for electric field. Okay, so that should be 1 upon 4 pi epsilon naught. You can take this common, and lambda you can also take common. right? And integration is from 0 to 2a, which is length, and only dy divided by x square plus y square would remain, and of course cos theta is there. So cos theta, if you will consider this diagram, if this is the theta, then cos theta should be base upon hypotenuse, because the side against a, or opposite to theta, should be your perpendicular. The highest side is, longest side is hypotenuse, and the remaining is base. So cos theta should be x divided by hypotenuse, which is r. Okay, so you can write here, that should give me this cos theta should be x divided by r, and this r nothing but x square plus y squares square root. Okay, so the equation should be converted into lambda divided by 4 pi epsilon naught 0 to 2a. So that is nothing but x divided by x square plus y square. This is power 1 and this is 1 by 2, so that should be 3 by 2 into dy. So you can see here that the horizontal distance of this point from the rod is always x. Okay, so that is not changing, only y is changing because of this r is changing. So x is constant here, so you can take this x out of this integration sign. So that is lambda into x divided by 4 pi epsilon naught. Integration is from 0 to 2a, and that should be dy on x square plus y squares 3 by 2. So now again what we'll do here is we would just put here the value of y, okay, to calculate x. So y will put x is equal to tan theta. Okay, so dy should be x into sec square theta into d theta, very simple. And then you can put this value here in this integration sign. Okay, and here one thing is to be noticed, that this 2a is for y and this is for y, that has to be noted down. Okay, so the integration would be lambda into x divided by 4 pi epsilon naught, and limit is from x equal to y is equal to 0 to y is equal to 2a, and then we have put this value here, so that is x into sec square theta d theta divided by, you can put this value here, so that would be x power 3, of course that would come out, and that would be sec cube theta. Other things would be cancelled out. Okay, 1 plus tan square theta, that becomes sec square theta, and sec square theta of 3 by 2 would be sec cube theta. Okay, so x cube would be taken out, so that should be equal to lambda x divided by 4 pi epsilon naught. That x would be multiplied with this, so that bit would be x square, and here is another x, which is x cube. Okay, and that is from y is equal to 0 to y is equal to 2. So only one sec would remain, and that would be cos theta to d theta. That is the only thing we'll get. Then integrate this sign, so that should give me lambda divided by 4 pi epsilon naught to x square would cancel out, and then that is sine theta, and that is the value for y is equal to 0 to y is equal to 2. That thing has to be kept in mind. Okay, that's very simple. Then what we'll do here is, now we'll just put the value here of y. Okay, so theta, so that can be written as, because we know that y is what, y is equal to x is to tan theta, right? So tan theta is y upon x. Okay, very simple. So sine theta should be, because tan is perpendicular by base, so that sine theta should be perpendicular by hypotenuse, and hypotenuse would be from this. So hypotenuse would be perpendicular square plus base square square root. Okay, very simple, and it is nothing but y square plus x square. So you can put this value here, so that would be perpendicular is y hypotenuse y square plus x square. Okay, very simple. And then you can put this value here. Right? Okay. So what you can write here is the electric field along x-axis would be sine theta when y is equal to 2a minus sine theta when y is equal to 0. Okay, and multiply by lambda 4 pi epsilon naught into x. Our focus is here actually. So sine theta when y is equal to 2a we already calculated. That is y divided by y square plus x square. Okay, and that is y is equal to 2a minus, and sine theta for this is 0 basically. So sine 0 is 0. Okay, and that is lambda divided by 4 pi epsilon naught into x. So now you can put this value of y is equal to 2a here. So that would be 2a divided by 2a whole square plus x square. Okay, now that is in square root, right? And then minus sine is 0 is 0. You can put lambda 4 pi epsilon naught into x. Okay, so the answer what we should have now is lambda divided by 4 pi epsilon naught into x, 2a square root of 2a whole square plus x square. And we know that lambda is q upon 2a. So when we put value of lambda here, 2a would be cancelled out. So that would be 1 upon 4 pi epsilon naught into q divided by x to square root of 2a whole square plus x square. So that is the electric field along x-axis. So you can write here I, which is the unit vector of I. Okay. So similarly, you need to calculate what is the electric field along y-axis, and that is very simple. So for calculating electric field along y-axis, you need to take what is the electric a small electric field component along the y-axis, and then you really need to integrate from 0 because it's the value of y. Okay, from y to 0 to 2. So you can put the value here. So that is nothing but dE into sine theta. We already know this thing, and then y is equal to 0 to a. Okay, so that is also very simple. Just you need to put the value of sine theta here and dE. We know it very well. So when we put this value, we should get 1 upon 4 pi epsilon naught lambda into dy x square plus y square. So that basically is the value for dE. Okay, sine theta is basically perpendicular by hypotenuse. So when we will see this diagram, so for sine theta it is perpendicular by hypotenuse. Perpendicular here is y. Okay, so y upon r, you can write. So that is y upon r, and r is nothing but square root of x square plus y square. So now, and that is for integration from y is equal to 0 to 2a. So you just need to remember that this is a limit for y. Okay, so before putting the value of y is equal to 0 and 2a, you need to change it in terms of y. Okay, while doing it. So let us try to solve this equation. So anything apart from y is a constant, so you can take it out. So lambda can be taken out, 4 pi epsilon naught can also be taken out, right? And any other term involving y cannot be taken out because that need to be integrated. But that's a variable and should be taken care of. So that should be x square plus y square power 3 by 2, because that is square root and that is power 1. That would 3 by 2. Okay, so now we need to integrate this in such a fashion that y should go. Okay, so let's consider that the x square plus y square here in this case, suppose for sake of simplicity, suppose is u square. Okay, so we'll just differentiate it, so that is with 2u into du, and because x is constant, that would be 0, 2y into dy. Okay, so it means that y into dy would be u into du. Okay, and then you can put this value here in equation 1, suppose in this case. Okay, so that should give me electric field along y-axis, should give me lambda divided by 4 pi epsilon naught, and that is from y is equal to 0 to y is equal to 2a, and all this we have to need to put this here. So y into dy basically here is u into 2a, 2u, u into du, and here you can x square of y square in place of that, you can get u power 2. So u power 2 and power is 3 by 2. So the 2 would cancel out and 3 would remain. So that should give me lambda divided by 4 pi epsilon naught, y is equal to 0 to 2a. Okay, and that is u into du divided by u to power 3. So one of u cancel out, so that should give me lambda divided by 4 pi epsilon naught, y is equal to 0 to 2a, and that is u power minus 2 du, because one of u is cancelled out, and then you have to integrate that one. So just add one of the power here, so that should be lambda divided by 4 pi epsilon naught. So I'm now integrating it, so that should give me u power minus 1 and you divide by 1, and that's for y is equal to 0 to 2. Okay, that you need to remember that that's limit is for y and not for u. Okay, so you can take minus sign common now out of that bracket. So now this can be done by solving that in this fashion, that ey is equal to lambda by 4 pi epsilon naught, minus sign I have taken common, and here this mu's power minus 1 can be written 1 by mu, and for y from 0 to 2a. Okay, so now here this is for y, right? So it means that u now has to be replaced in terms of y, and we know that u square or x square plus y square is equal to u square, and so u was basically x square y square root. Okay, so in place of u, you can write square root of x square plus y square. Okay, and then y is equal to 0 and y is equal to 2a, so minus lambda divided by 4 pi epsilon. Now basically you can put this value of y here and can find out what is the value for this. So that would be minus lambda by 4 pi epsilon naught 1 upon x square plus 2a whole square root. Okay, and then minus 1 divided by square root of that y square. Basically we can x 0, so only x square under root would remain. Okay, and so that would become lambda by 4 pi epsilon naught, that would be x, so 1 by x. I have taken this minus sign inside this bracket, so minus would become plus and plus would become minus. So 1 upon square root of x square plus 4a square. Okay, so that is the equation, and that is of course along the y-axis, so you can write j. So the net electric field you can write, and that was okay. So the net electric field would be electric field along x-axis plus electric field along y-axis. Okay, so that would be equal to, we already have calculated what is the electric field along x-axis. So along x-axis, that is the electric field, and along y-axis, that is the electric field. So you just can add these two and can write in terms of I and j. So that can be written as, okay. Also this lambda can be replaced by q upon 2a, right? So I'm just writing here 1 by 4 pi epsilon naught q divided by x, then 4 times of a square plus x square, and that is my ith term. And then I can write the y term, which is this one, and lambda can be written as q upon 2a. So that would be basically q upon 2a means 4 pi epsilon naught into 2a. So you can write 2 into a, and here that would be 1 upon x. This is the final expression we have derived, and here the coefficient before of the ith unit vector representing the electric field along x-axis, where the coefficient of j unit vector representing the electric field along the y-axis. So that's it, friends. If you like this lecture, you can click on the like button and subscribe my channel, so that such more videos you would be able to see. And thank you for watching my video. Thank you very much.